Good afternoon, and thank you very much for allowing the time to join us today. My name is Charles Scott. Welcome to this month's Civil Designer Software Open Classroom webinar. If you're new to our webinar series, please visit our website www.civildesigner.com. Go to the Services pull-down menu and click on the Webinars link to access our library of past webinars, totaling 79. Or, under the same Services pull-down menu, click on the FAQ videos link to access our library of short, searchable videos created from this series by typing your topic of interest in the search bar, be this importing various types of aerial imagery, working with point cloud data, modeling existing as-built information before you begin your new design, to exporting BIM workflow design information. This library of around 500 videos covers many topics. Please feel free to use this resource at any time. In today's Open Classroom webinar, I'm going to be joined by Andrew Cole for an advanced roads session using the latest version of Civil Designer, version 8.5 Build 6. During Andrew's presentation today, please feel free to use the text chat service on your GoToWebinar app or web page to ask us any questions you may have during his time today. Andrew, it's been great working with you again. Please take it away.
Thanks, Charles, and welcome everyone to this month's Open Classroom webinar. In today's webinar, we're going to be looking at the section editing menu in Civil Designer's Roads module. I've had a few clients recently asking me to assist them with very specific road volume calculations. And to get the required result, we had to make use of the road cross-section editing functionality. And I thought it would be a good idea to cover the section editing functions that we use in this month's Open Classroom. So for example, if you look at this drawing, we've got a road rehabilitation and widening design over here. And if you look, these are the existing road edges. And the box cut is going to have varying depth. So you've got 400 over here, where you've got the existing road layers that are being rehabilitated. And then over here on the new widening section, you're going to go down 700. So you need to create a custom road box, and that you can do by using that section editing functionality. Okay, so that's one example that we can have a look at, and then some other examples that we can look at today. Okay, so let's have a look at that section menu in the roads module. So some of these functions you will be familiar with. For example, the graphical edit that you would use to view your cross sections, the ground cross sections, your design cross sections through your road. You've also got list sections that you can use to list your actual coordinates, the road centerline, road edge coordinates, for example. And then the solidify layerworks, I'm sure some of you are familiar with that as well, to create additional cross-section layers for your layerworks, for example, or your box cut. And then you can create custom volume calculations using that solidify layerworks. Before I continue, I think it's important that I mention, for those of you that are new to Civil Designer, today's webinar is really going to be covering customized volume calculations. When doing a normal design in Civil Designer, your roads or development roads, the volume calculations are fully automated. So you've got this quantity report where you can see all your volumes for all your roads. You can do custom reports. You can check individual roads, your cutful areas, your layerwork volumes. So that is fully automated. And today's exercise is basically just to do very customized and more detailed volume calculations when it's needed in special circumstances. A lot of the section editing functionality that we're looking at today is more applicable to our traditional cross-section road design. These days, when you're selecting a road file to work with, you'll notice that we do have the traditional cross-section design available, but the more popular way of designing these days is with a strings road. The benefit of a strings road, which this one is as well, you can see over here in my properties bar, it's a string road, and you can toggle between the cross sections and the strings, but the strings is a much more powerful way of designing. You have dynamic contours that update as you make changes to your road design. You've got junctions, all your junction designs that you can do with a strings road, mini roundabouts, your Stockdale, all the cul-de-sac shapes that you need to design, and everything dynamically linked. So as you make changes, then everything is recalculated, your layouts are recalculated. So probably the preferred way these days is the strings road. And then linked to that, we do have some regression functionality as well, which allows you to do road widening from CAD lines. You can extract your stake and vertical alignment from CAD entities as well. So very useful functionality linked to a string road. And a lot of this then also supersedes a lot of the section editing functionality that we used to use. So for example, you've got the regression where you can extract layerworks from CAD. So you could have CAD lines on the widening of a new road, and you can just work out the layerwork volumes for that widened section now with this function. So a lot of useful functionality now available with strings. But for today, I'm just having a look at the section editing, which can still be used in certain circumstances. Okay, so let's start off with the section graphical edit function. I'm just selecting chainage on my road. The other option is to press escape, then you go to the start chainage. But if you want to be at a particular chainage or point of interest in the road, then you can click on that chainage. So in this case, chainage 3140 that I wanted to look at. So yeah, we've got our ground design cross section, and then the actual road final design cross section. Okay, this cross-sectional data is stored as an offset and elevation pair. So when you're extracting your ground cross-section data, these little vertical lines indicate those offset and elevation pairs. So negative traditionally would mean left of your alignment, left of the center line. So that's the offset, and then the elevation. So this is for the ground line. And then the same thing for your road design cross section. We'd also save an offset and elevation pair, road edge. You need to set the active line before you can interrogate those cross section points. So I'd go edit point now. And that would be, for example, my shoulder break point, the road edge point. So offsets and elevations. Same on the right hand side, that would be a positive offset for my right road edge. Okay, so we're saving that information as an offset and elevation pair. Okay, so when Civil Designer calculates your mass or volume, it's calculating this cross-sectional area between your ground and your design layer in this case. So this would all be cut. But we traditionally using the end area method. So average area between two cross sections multiplied by the length in between them to calculate the volume. The volumes for the junctions are calculated slightly differently with prisms, etc. But traditionally on these sections of road without the junctions, we're using the end area method. So it's important that you know how to edit these cross sections and make sure they're correct for the exact volumes that you'd like to calculate. Okay, I've been using the R shortcut key to redraw to the cross-section limits, but you have got the functions on the toolbar over here that you can also use. The top icon is also redraw to alignment limits. You can look at the description down at the bottom left of the dialog. So same thing, I could just click on that to redraw to those alignment or cross-section limits. The other icons on the toolbar, just to mention quickly, we've got a zoom window. So you can just click and drag to zoom into an area, and then R to redraw. Okay, so if I want to zoom into an area, it's just a left click and then drag and release. And R to redraw again. If you want to pan, just press in your mouse wheel like your normal pan. You've got an exaggeration setting, the vertical exaggeration that you can set. Generally I use about 2 times exaggeration, but sometimes if you want to see variations in your surface, you can exaggerate it further. Then we've got these edit point functions over here. So you've got insert a point, edit, delete or move a point, so cross-section point. Those editing functions only work on the active line. So let's just have a look at that quickly. If I go to the line settings over here, not going to save any changes. The active line you can set over here, and that is the line over here relating to these line numbers. So line 2 would be my final row design layer. So I could edit those points on line 2 currently. So you'll see if I go to edit point over here, I can click on a point. I'd be able to change an offset and elevation, for example. I could delete a point if necessary. Those various functions over here, the point editing functions, are available on a right click as well. Inserting, edit, delete and move a point. Your layer details, those are those settings, the line section line settings. You've got up to 50 cross-section lines that you can display. Your normal template layer works that you can have visible, your curves, a whole lot of additional settings. I won't go through all of them. But the longitudinal grade is quite useful, as well as this cut fill indicator where you can set a tolerance, let's say 3 meters. So it'll indicate where you are deeper or higher than 3 meters in cut and fill, so you can identify where to position guardrails and etc. Okay, so the other function I just wanted to mention was this move section, which physically allows you to actually move your current active layer, road cross-section layer. So just asking me which is the base layer that it's got to move it relative to. So I'm going to move my design layer relative to our base ground layer, just to show you. You can actually move it something like that, and then it'll apply those template conditions based on where you're moving it to. Now, something to bear in mind when you editing these cross sections like we're doing over here today, it's not having an effect on the vertical alignment. So this is independent of the vertical alignment. So if you had to go back and regenerate your vertical alignment levels, regenerate your edge levels, apply your template, it's going to override these changes we're making over here. So these changes that I'm looking at making today are basically for volume calculations based on these edited cross sections. The edited cross section that we've now changed, for example over here, would then be used, the levels from this cross section would be used to generate the volumes. It'll be used to generate long sections as well as your cross section drawings. So just something to bear in mind, that this is independent and doesn't update your vertical alignment. So there are ways to get around that, to re-extract your vertical alignment based on these changes, but we won't be covering that today. So today's cross-section editing that we're looking at is purely for volume calculations and for plotting cross-sections or long sections based on these changes. Okay, so I'm just going to use the page down key. So you need to click on your cross-section. Remember, page down to drive down the road in the increasing change direction. So I'm not going to save the changes to this cross-section. And then I'm just going to page up again. Page up is going in a decreasing change direction. So I just want to show you some of that editing that can be done over here in the cross section itself without the section menu. So looking at something like this, if I zoom in over here on this side, you don't really need this full bank over here. We're in cut on this section, so you don't need to add that additional berm on the side there. So what you'd need to do then is delete these points. So a couple of ways to do it. You can go into your section editing, and that brings me to a few more of these icons over here that we didn't mention previously. You got a grid that you can display to see vertical, horizontal spacing. You've got this track cursor position that we can look at, and then you can print your cross section, and then you've also got this component panel that you can go into. So you could go, in this case, left cut and fill, and we can start deleting these sections. If you right click, you can actually go and delete some of these components manually. So I could start deleting them from there, for example. Okay, so that would be one way of doing it. The method that I wanted to show you over here as well is the functionality on a right click. So you've got this line intersection option over here. So I could just physically delete those points on that design layer, now the active layer. But then I wouldn't have an intersection point. So what I'll do first is insert a line intersection. So it's going to create a point where the two lines intersect. So this is this bank line over there and that ground line. So it's inserted a point for me over there. And now I can delete those other points. So that line intersection would be necessary over there. Another reason for line intersection would be if you're doing a polygon area and you don't have a point. So you could do that polygon area over here, and you click on all your points on the cross section to calculate an area. And then you would need a point there at the change of direction as well. Okay, then I've got another cross section. If I just page up, yes, I want to keep that change. Page up again. There's another one over here that I'm going to edit. So just the same thing. I'm going to do a line intersection over here between that one and that line. You can see it inserts the point, and then I can delete these additional points on the active line, so it won't be deleting my ground points in this case. And then just a page up or page down again, I do want to save those changes. Okay, then we're going to close cross-section editor. And we should see those cross-sections updating. So we had those full bank shadings on the side of the cut section, so that's gone now. Okay, so that was the cross-section editing, sort of the manual editing of the cross-sections. Now we're going to look at that section, the section editing, which is a global edit across a range of changes. Okay, so I'm just going to zoom into an area here. Okay, and then I want to look at that. It's this functionality where we actually go and create a box cut with the various depths over here of cut. Okay, so we're going to look at one or two of these cross-section functions to achieve that box cut. So the first thing, let's just have a look at that cross-section again. In the cross-section editor, if you want to go to a particular chainage on a long road, you can use the G shortcut key to go to a particular cross-section at a set chainage. You just type in the chainage, click OK. So in this case, I've gone to the start of the road just to show you this cross-section, which is a little bit closer to that client's scenario that we're looking at with the box cut. So in his design, he had an existing road survey and they were doing some rehab of the layers and some widening on the road. But I've decided to use this section of the road that I had in view previously, as I can illustrate that intersect with batters in the solidify layer works a little bit easier on this section. And I'm just trying to really show you how to use that interpolate and absolute change functionality. Okay, so I'm going to create some additional layers over here using the solidify layer works functionality. There are a couple of ways of achieving a box cut. If you go to this section solidify layer works over here, you can essentially, with this solidify layer works, you're creating additional cross-section layers. So specifically for your pavement layers. So you can do the last layer work, that would essentially be a box cut, and then you've got the options to intersect with the left and the right batters, the batter slope over here in a full situation. The other option is to do all your layer works, and you get cross sections for each pavement layer, a full cross section, which then also allows you to calculate volumes. There is also an option over here to step it in full only. So you'd only get stepping if you were in full. In a cut situation, you just get a vertical side to your layer works. I'm just going to run the last layer work for now, and I want to intersect on the left and the right in this case. Okay, and then if I look at those sections now, once it's updated, I'm going to go to these line details, the line settings, and I want to switch on that bottom layer. So in this case, it's my line 6. You can see we've created a full cross-section line over here. So it's taken that bottom pavement layer and it's intersected with the batters over here. So it's created a cross-section layer. If you didn't say intersect with batter, then it would go up and intersect over here vertically with your design cross-section layer. Let me just switch off these pavement layers now. We don't need to view that at the moment. Okay, so before we edit our cross-section now, I just want to look at that rehab and widening drawing just to recap. So we're going to be doing something like this, creating a layer with a different depth from the design surface down to the box cut layer over here. So you effectively would need 2 points. You need a kink point and then a point to lift up in that cross section. Okay, so just going back to our project drawing now, we're going to go to section graphical edit. I just want to show you. So what I'm going to do, I'm going to model something similar, just 3 meters either side of our alignment over here. We're going to insert 2 points, and then we're going to lift the 1 point, the inside point on each side, a certain height. Okay, so you always verify what you're doing in that section graphical edit. So we're going to go section, and we're going to use this interpolate option. So the interpolate allows us to add points on a specific layer. So you've always got, with these functions, you've got a process layer, and then you're storing it to a layer as well. So in this case, we are actually processing that bottom layer of our pavement layer works, and we're storing the data back to the same layer, bottom layer. You've got a couple of surface actions here that you can apply. You can add points, which effectively keeps the existing data and adds additional points. The overwrite would delete everything on that layer and then add additional information. And then the merge is only available on certain functions where you would keep a portion and then, let's say, delete the middle section, and then those new points you're generating would be added to that middle section. So you're keeping a portion and then deleting a section and adding new points on the deleted portion. Okay, and then a couple of ways to define where you're working. You can use offsets from the center line, or you can use your point location codes. Okay, and then you can do them individually, or you can do the whole chainage range that I've selected in this case. This verify allows you to stop and verify the changes from chainage to chainage. Okay, so just clear the list. I'm going to add a point at 3.1, and then just quite close, another 3.11, and then on the negative on the left side as well, 3, so negative 3.1, and then negative 3.11. Okay, so I want that vertical face just to be slightly offset, so I'm going to use that 5mm. So you could even do it closer than that, but that should be sufficient for our purposes. If we go and have a look at that cross section now, so we've got those points pretty close together. Okay, so essentially we've added that point so we can then lift this point up. If you just had the one, then it would kink from there up to there. So we're going to lift this point up, and then we'll have this vertical face. And the same on this side. It's going to kink on there and then lift that point, cross-section point up. Okay, so that was the interpolate function to add those points, and then we're going to do the section and absolute change. So the absolute change, once again, we're processing layer 6 and storing the information back to layer 6. We're going to be doing the whole chainage range. We're using that offset distance to verify the position of the change. Okay. So over here, I've got 3.1 and 3.11, so I'm going to go negative 3.105. So between the 3.1 and the 3.11, and then this side as well, 3.105. We're applying a value as a constant to the elevation, and I'm going to just make it 200 in this case, just for this example. Okay, so we left limit, just make sure that's a negative, and then your right limit. Okay, the absolute change allows you to move things horizontally and vertically, and you can also have a taper, so you can have a 0 start and a 200 end, for example, and have a vertical taper, or the same if you're doing it to an offset, you can have some sort of horizontal taper as well. But in this case, we're just doing a constant height or elevation that we're adding to those points. so let's have a look at that cross section now. Okay, so that's basically what I was trying to illustrate, was to get this, the layer, the bottom layer, to kink, and we've created two different depths from your design surface down to your bottom layer. Okay, just show you that G to go to, that's the shortcut to go to a chainage. So this was essentially what we were looking to achieve. So your ground line wouldn't, in this case for a box cut like this, the whole scenario wouldn't be in full. But essentially I'm just trying to show you how that interpolate and then the absolute change would work. Okay, so the scenario that the client had would be closer to this cross section. Okay, then moving on to the next example that I want to show you today, and this is the Solidify layer works. So we've already had a look at the section Solidify layer works previously, but in this example I want to show you how we can use the additional cross-sectional layers that we create with the Solidify layer works to calculate your layer work volumes. So just looking at the cross section on this road design, when we calculating the layer work, the pavement layer work volumes in Civil Designer, we use the lane widths as defined in your edge levels, with lane widening, etc., all taken into account, as well as any stepping in your layer works as defined in your templates. And then we also obviously look at the depth of your pavement layers. So we're using those cross-sectional areas once again, and then just multiplied by the length of your road. But if you want to, for example, in a case like this, carry your layer works through to your batter slope, where you have a design where trucks are pulling over to the side of the road, for example, and you have to take your layer works through, then you'd have to run the Solidify layer works to take those additional areas into account with your layer work volume calculations. Okay, so I'm just going to run that section Solidify layer works again for this road, and in this case I'm specifying all layer works, and I'm intersecting with the left and the right batter over here. You can close this dialog. Still going to run through the whole calculation, so you don't have to view that if you've got a longish road that you're calculating. Okay, so let's have a look at those new cross-section layers that we've generated with the Solidify layer works. So I'm just going to go to the section lines and make these additional layers visible. So if you run your layer work volumes, then we're calculating in this case up to this point. So let's just switch off those pavement layer works. And then you could run custom quantities, these pavement layer quantities now, to include these areas. So the way to do that, you'd run the normal Massel volume calculation between that cross-section layer and this cross-section layer. So you'd have to do them all individually to get a very specific layer work volume in this case. So it would just be area volume, Massel volume. I'll just set everything to 0, and then you can do the layers, the individual layers, for example, between the G7 and the G9 now. You'd calculate that. So essentially we're calculating the volume of material between those two road cross-section layers. And then you can view the results, which in this case is the volume of G9 material. I was hoping to cover more of the cross-section editing functions today, but I've run out of time, so we'll have to leave that for a future webinar. I trust that today's webinar was informative, and thank you for watching. Until next time, cheers from me, and back to you, Charles.
Thank you very much, Andrew. That was very interesting. We will shortly be posting a video copy of today's webinar on our website's webinar page. And by around midday on Monday, we will have posted the FAQ videos created from today's session on our website's FAQ video page. Once again, thank you very much for allowing the time to join us today. Please follow our company page on LinkedIn if you have not done so already, where we post our latest customers' civil designer project showcases, relevant industry news, and all the new civil designer software tech tip videos. Please have a great afternoon, weekend when it arrives, and goodbye for now.